This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
Good afternoon. Since you submitted the PCB, we will be discussing about the PCB fabrication and PCB tracks. So you should be knowing how your PCB is being fabricated, and then there are some important aspects of PCB tracks, which is not required for your DSO, but the track, PCB track, like how to match the impedance. Sometimes there will be a requirement that you may have to match the impedance of the track 50 ohms. So how will you design it? So by the way, anyone did not submit the DSO design here, or all submitted? Okay, that is good. Suppose you did not submit, so we will give you one more option. You can fabricate at outside. And no, it's not a joke. You can fabricate outside PCB where there are some companies in China, they will give you like PCB in a week time. But then you have to pay from your pocket. Not very expensive. Means you should have a DSO board. So I am not going to leave you without a DSO board. So you can fabricate outside. Then when you fabricate outside, when your board comes back, in order to solve, before soldering, you have to send us your design. So I will post it on LMS to make sure that that is your board. Because your tutors will check it on LMS, some similarity with your design. Then you can solder it. So we will give you one more chance. If you haven't submitted, you can fabricate outside and send me or your tutor the design. Then you can start soldering. If you made some mistakes, usually the mistakes may be okay unless you make some problem in the high frequency clock. Other issues are we can sort out. You can put a jumper, cut the track. So better to buy a knife and keep it, small knife for cutting the track if you made the mistake. Because the PCB manufacturer, they will not check your design. So whatever we submit, they just fabricate. Obviously they said they are happy to check, we are happy to check it, but then they said that will take obviously a month. So we can't afford, so we will give time only 1 week for them to fabricate. So your tutors are working overnight, so many emails, because this they don't accept like your one file. They have to put it as a panel of 8 in a particular way and check it. Then only we can submit. So lots of work. So that's the reason we have to make your DSO working. So if you, again I will post it on LMS. If you haven't submitted your DSO file, you can fabricate outside. And once you get the board, you please email us your design. And then you can also show your board to your tutor, say that you fabricated outside. So we will not reduce any marks if your DSO is working. So PCB fabrication, and last year the students went and saw the PCB fabrication in Dandenong. There was a company called PCB Way. So they fabricated PCB for DSO last year, but then now end of the last year they shut down because they couldn't compete in the market. Their boards are expensive. So there is an opportunity here for you to start a PCB manufacturing company, but the challenge is the cost. So they shut down because they couldn't compete with international companies where they fabricated boards for cheaper price. Having said that, our department, electrical engineering department, we have got a PCB manufacturing capability this year. We can fabricate the PCBs, and we got a pick and place in my lab. So milling. So PCB initially they fabricated. What they have done is they take a copper coated substrate. Say they deposit copper on some substrate, then they mill it on only one side. So this machine with the spinning drill bit moves around and removes unwanted copper was used in this department. So our department also had a milling machine not being used now in the past. No chemicals, quick and easy, limited track width, no vias or through hole plating. So this is just for mounting the components. What they do is very simple. So you got a surface FR4, then you deposit the copper. Then they got a drilling, then they will drill it and remove the copper, and then they make the track. So something similar we have got in the department, but a bit more advanced. Yes, the milling, this basic milling was available in our department, But now what we have got is a proper PCB manufacturing like in a company. Then we also got another facility called laser writer. So laser writer means again you take a substrate, then if you got any metal, gold or copper or silver, you deposit it and then you put in a mask. Then laser will cut out that pattern for you. So you can make a PCB. Some of my students made a PCB using that one. But then the problem is it's only one single side. You can't put any vias. Then you can't make use of the back plane. Everything should be on the top. Quick prototype might be useful. Low frequencies, quick prototyping. So this was the first PCB. Then what happened is later came copy and etch. So trace design into a blank board. Use a resist pen to protect parts of the board. Put into etchant, then clean off resist pen, drill holes. So what they will do is maybe if you visit the National Geography's shop or somewhere, they have got some pen, draw your circuit. Have you seen? Because I was there in a shop last week with my son. He is 5 years old, but he got interest in all these stuff, fancy stuff. And there what you can buy is you can get a pen and then there you got a board, then you can draw your circuit. And then what they do is when you are drawing, that is kind of a conductive track. So here what they do is trace design into a blank board, then use a resist pen to protect parts of the board. Means you have got coating and then they write it with a special type of pen. So wherever you have written, that underneath copper will stay there. That's kind of a protection. Then remaining part you can etch away in the acid. And then drill holes. So that is called copy and etch. This is a bit more advanced. It is called photolithography. So photolithography is not only used for PCB fabrication. So this is what often people use in all the companies, photolithography. So here they make a mask. So that is the reason they need your Gerber file. From that they are making a mask. Then they are transferring that mask into your PCB and then they develop it. So print out artwork into a transparency. See, they will print out your design into a transparency. The transparency, transparency. Then drill holes into the PCB blank. So they take a blank PCB and as per the design they drill the holes. Then what they do is they coat PCB blank with the photoresist. So this is kind of a polymer. It is called photoresist. So this is sensitive to the light. So that is the reason it is called photoresist. Then place artwork into PCB blank. Then they will put it on the top. Then they expose to UV light. Then they can develop etch and clean. So I got some slide to explain it properly. So that is coming. Yeah, so photolithography. So you should be knowing photolithography. The term you should be well familiar as an electronics engineer because your ICs are fabricated using photolithography. All the ICs in the foundry, they use photolithography for fabricating your transistors, for fabricating your image sensor. All these things they use photolithography. So this is based on light, UV light. They use UV light. The idea is very simple. What they do is, suppose I want to make some design, something like, I can show you. Maybe I have to make something, one track like this, some spiral here, then something like this. See, this is my design, simple design. So if I want to make this design, what they will do is, they will print this design into a transparency. So when I print this design, I will print it and then make it into a transparency. And then what they will do is, so I want to make this structure into here. Then what they will do is, I take this substrate. So this is your PCB and then this is coated with copper. So this is a copper plated PCB. Then I want to make this pattern on here. So it's easy. Then they take this one. Then they got a spin coating machine. Spin coating machine means it's a spinner. Then I put it here and the spinner will rotate very fast. Then I put some resist, some polymer, that's a liquid. Then that will be covering. And then this polymer thickness we can control based on how much fast you are spinning. You know what I meant? So you are coated with this polymer. After that what you will do is, then you got a mask aligner. So that will align this mask on the top. Then this polymer is sensitive to UV light. So send the UV light down. Then what will happen is wherever you got this masking, the UV light will not react with the polymer. You know what I meant? And the remaining area it will be reacting. And then you take it off and then put it in a solution, and then that will remove all the places where UV light hit on this polymer. Then you are getting that copper only is exposed. So I can make this pattern. So I got a slide. So this slide will give you a good idea. So our idea is we want to make, how to make this structure. This structure means this is a silicon substrate, and then this is one track, this is another track. So in your case, this is maybe a FR4 board, that is a dielectric. So this is copper, this is copper. So you got two tracks coming in parallel. How to make it? That's a simple structure. For that, you will be designing this track on the Altium, then you will be getting a Gerber file. From that Gerber file, we will make a mask. So we will measure, okay, this is the gap here, so we need that gap here. So then here you need the track, here you need that track. So then here it will be black, here it will be black. So that's the reason we make a mask. Then we will take the silicon or FR4, any of these material, the substrate. So in your case, I am going to use silicon, not silicon, FR4, because that is a PCB material. And then what you will do is, you take the FR4 material, and that material is already deposited with the copper. So this is your copper. So you will be taking a PCB. On the PCB, you already got FR4 that is deposited with a copper thin film. That is a copper thin film. Then you will put the photoresist on the top. See, that is using a spin coating machine. You can deposit the photoresist. Then what you will do is, then you will take this mask and put it on the top, align it, and then you allow UV, ultraviolet, this UV radiation to hit your substrate. Then what will happen is, because here you got a dark, the UV cannot react here, but then this part UV will pass through and react here. And then what you will do is, after maybe a couple of minutes, you will put it under UV light, and then you remove this mask and then put it in a chemical. That is a kind of a photography development. This is called we develop it, putting in a solution. When you put in the solution, wherever the resistor was there, and then that is exposed to the UV light, that will be going away, because the solution will remove only the part that interacted with the UV light. So that's the reason it is called photoresist. It will react with the photons, light. So this UV, here it is interacted, but here because of the dark pattern, the UV is not passing through, so that this polymer, this part photoresist will not be washed away. Only this part got reacted with the chemical, because UV light is falling only in this region. See, now you got this part. Then what you will do is, you put this one and then you can do etching. So etching means either you can use some gas etching, or again you can use some chemicals. So then what will happen is, here you got some copper etchant, maybe some chemical. When you dip this one, what will happen is, because you got polymer here you got polymer, this part will not be etching. So then you will be, only this copper will be gone. So that is the reason this part is gone. Then you will be removing this polymer. Maybe you can dip in another solution that will remove this polymer. So see, now you got the copper track. So that's how we will be making. And then that's how you will be making your chip. So I have put silicon substrate, because transistors are fabricated on silicon. So that's how you make transistors in your chip. So all the foundries use photolithography for designing the chip. For PCB design also we use photolithography. And then this happens in parallel. So all the patterns you can make it together in a single run. It got multiple stages, like 1, 2, 3, 4, 5, 6 stages, but it's all 6 stages called one run. So that's how we will be fabricating. Then photolithography, as I said, you should be knowing the photolithography, because this is very important technology for an electronics engineer, because of the chip fabrication. Then photolithography, people might ask why people are using UV light, why not white light? Because you should be asking these questions. Why people are using a UV light, not white light? And then Another question people often ask is how you can fabricate, process technology. We already studied in the ECD. Now we have got maybe 12 nanometer technology, semiconductor process technology, 28 nanometer technology. So can you fabricate 28 nanometer using this technology? Definitely you can fabricate. And so they don't use light. Why? Because our visible light got a problem. So visible light got a problem called diffraction. So diffraction means when your wavelength is 1 micron. So when you have one wavelength equal to 1 micron means then your wavelength is something like this, 1 micron. And then this 1 micron, even if you are putting a very good lens, you cannot focus into a point that is your focusing is approximately equal to lambda by 2. So that will be the focusing spread. You cannot focus down, sorry. Yep. So when you have 1 micrometer light, it's called a diffraction. So when you have 1 micrometer light, even if you are trying to focus the light, then what will happen is this focal length will not be a sharp point. It will be around lambda by 2. It's not approximate, it's not exactly around lambda by 2. Means if you got 1 micrometer, your resolution is going to be 500 nanometer. So that is that much only you can focus because of the diffraction, no matter whatever lens you put there. Then your resolution is 500 nanometer. Then if you want to increase the resolution, means then your minimum pattern size you can fabricate is 500 nanometer. So that is not good. But then if you come to visible, so visible light is 400 nanometer to 700 nanometer. That is the visible, VIS, visible range. So visible range, if you are using 700, our resolution will be around 350 nanometer. But if you are using 400, our resolution will be 200 nanometer. Then after this one is a UV. So UV means you are dealing with maybe 300 nanometer or 280 nanometer. So that is the reason they are using UV. So when you are using say 280, your resolution is around 140 nanometer. So that's the reason they are going for UV. Then extreme UV is used these days. Then it is going maybe below 280, and then you are getting around maybe, I don't know, 120 nanometer. But then you can see still you are getting only 120 nanometer resolution. But then how people can get 28 nanometer technology? Because 28 nanometer technology means the width of the channel. So 28 nanometer means using this technology, you want to fabricate 28 nanometer technology. 28 nanometer technology means you got the MOS, then this is the drain, this is the source, then so this is the channel, and then this is your gate, and then this width, that's equal to 28 nanometer. So how can you make 28 nanometer? But even if you are using a 280 nanometer or 240 nanometer, you can get only 120 nanometer around resolution. So then they will be using some computational techniques, and then they can get around 28 nanometer. So still they are using photolithography to get to this nanoscale. So that is the reason we are using UV or extreme UV light, so that your resolution will be much better. In your case, your PCB track is in millimeters. We don't need this UV light, even extreme UV, but still they use UV so that it is accurate. So that's how we make chip, CMOS fabrication. CMOS chip fabrication, so you should be knowing photolithography. So somebody might ask you, how do you fabricate your chip? Then you should be knowing photolithography. Then what is photolithography? We already got the slides, so you should be understanding. So this is how they make the chip, photolithography, and your PCB. So PCB design steps. As I said, see, if you are using photolithography, then they will be printing your design. This is your design into a transparency. Then they have got the shear raw material, that is with the copper, two sides. Then they will put this one on the top, and then they make the drill. They drill the holes. As per the design, they know that where are the holes required. See, using this one, then apply the copper in hole barrels. Then they using the photosensitive material. They will be depositing on that one, then they will be doing the etching, and then they put solder mask. Solder mask is the green color that you see, because that is for protecting your copper from oxidizing, solder mask. So this is our PCB design step using a photolithography. Well, I haven't shown all the steps, but these are the main steps. And then the main concept you should be knowing is this photolithography. And then using photolithography only we make the PCB. And when you have a PCB, people might ask why it is green. Have you seen some other color? Yeah, there will be some other color, because the finished PCBs rarely have bare metal, as it tends to corrode and make it harder to solder. Means when you have PCB, it is made of copper. Copper will oxidize. So we have to prevent oxidizing copper. So they will be putting some protective layers. And then, so this one is called a solder mask. See here, that is a solder mask. And then here, clear lacquer. So this one, the green color. And then you will have silk screen. Silk screen is mainly for writing letters and drawing this white line, see, mainly for writing. Then tinned solder reflow. Solder reflow means here you don't see copper, but then they will put a tin, they will put it here so that it is easy to solder. So in the PCB, you don't see the copper outside. You always see the copper is, the color is copper, the color of the copper is different, but when you see PCB, you will be seeing this silver color. So the silver color is not the copper. So these are, they putting solder mask, they will be putting tinned solder reflow, so that you can solder properly. So these are for, so that even though you make PCB, then you have to do all these things. See, the PCB fabrication is a bit complicated. Then solder mask. As I said, polymer coating, typically green. So that is the reason you see the green. Applied over board and track, but leaving pads exposed. So the solder mask, that is the solder mask, after fabricating the PCB, they will be putting a polymer. That polymer's color is green. So if you got another color, then you will have another color. Most of the time it is green, the polymer. That is called solder mask. Why we need the green color is to protect the track from oxidizing. And then the pads, on the pads there will not be any coating. Then it also helps your solderability, resist solder sticking to it. So otherwise what will happen is your solder can stick on that one, but then this one is kind of a smooth, the solder will not stick on it. Reduces solder bridges between the pads, reduces oxidization of the copper. So oxidization of the copper is important part. Then also it is increasing the solderability. So that is the reason your PCB got green color. Then please don't tell that the copper got green color. So PCB, somebody will ask you why it is green color, then you can say that they put a solder mask, that is a polymer, they coat it on the PCB so that your copper will not oxidize, and it will be everywhere on the track. See that on the track also you see the green, but then they will not deposit here, then you will not be able to mount it, the components. See, they will be carefully depositing. So this on the track, they definitely they put it, because track is made of copper, so they don't want to have oxidizing. But then they will not put it here because you will be soldering. They will not put it on the pads because you will be soldering. So remaining part you will have the green color. So that is due to a polymer, it is called solder mask. Then silk screen. So silk screen, we already said, somebody will ask you, do you have silk screen on your PCB? Then you should say that no, silk screen. Are you joking? What do you mean by silk? So silk screen means the writing, see. So that is called silk screen. So that is in the PCB, somebody says silk screen means that is also called a nomenclature. Nomenclature means for writing the numbers, names, for giving the names. Typically white labeling and line arts. So white labeling, so that's the reason I said here this is a silk screen. And then all these numbering, whatever you want to write, you will be using silk screen for writing. Then component outlines and designators, other information includes name, version, then is for human readability, so you know where it is R1, R2, etc., where you have to put it. Component, which component, and then it's basically for nomenclature. Nomenclature means for writing it. So you know where to solder, where is R1, where is your C1, C2. You need to write it on the PCB. For that we will be using the silk screen. Assembly. So the primitive one is hand solder components. So you also will be using hand soldering. Then in the big electronics companies, they have got pick and place machines. So when you are manufacturing one particular board, particular design, you want to make thousands of them. So what they do is they use pick and place. Pick and place machine means you already get the Gerber file with all the components. Then they can load into a machine. Then they mount the surface components. They got it in the big reel and load it in the machine. And then the machine will pick and place on the PCB. So if you haven't seen pick and place, I have got a pick and place in my lab. We bought one pick and place. We are not doing any mass production, but it is for mounting some complex ICs. So there we can load 32 different components, around 32 reels, 32 different components, and those components we can connect to it, and then you input your Gerber file, and the machine will pick up each component and then put it there. First we have to put the solder paste. So yeah, when you are using pick and place, what you do is they make a stencil. You have to make a stencil. It is called stencil, means wherever the solder should go, because this is your PCB. See, when this is a PCB, you need to put first solder paste. Now when you put solder paste, you don't want to put solder paste here, you don't want to put solder paste here. Your solder paste should be going in the pads. Then how will you make sure that it is only going to the pad or only on the resistor or only on the capacitor? When you have to make a stencil. Stencil means then you have to ask the company to make a stencil for you. So that is basically a mask that when you put it on the PCB and then when you align it, you only see the pads exposed. Remaining things will be blocked. You know what I meant? It's kind of a mask. So you put the stencil on it and then you put the solder paste like this. Solder paste. And then the paste will only go to the pads, like here, these pads. Then what you will do is you take that board and put it in the machine. So the machine will correctly pick up the components from your Gerber file. It knows that where is R1, where is R2. But then design should be same. Because it will be doing, once it is finished, then you put another board in, and then again it will do the pick and place. In DSO, we can't use pick and place machine. Why? DSO, the project is same, but your designs are different. So we can't use pick and place. Then what will happen is pick and place, you load one design, it will finish one design. Then you have to change entire thing. Again you load it because your design is different. But if your board, you want to make, say, you want to make 1,000 copies of your DSO board. And then it is easy. Only one design, then it can make 1,000 boards maybe in 2-3 hours time. So in industries, they use this pick and place machine. So I have got a basic pick and place machine, not very well advanced. So in industries, you can have a big system pick and place machine. Then after pick and place, what will happen is your IC is on the solder paste. Then you will be putting in an oven, and the oven is heated up, and then this solder paste will get melted and bond it to your components. And then in my pick and place, oven is a separate one. So once you put the pick and place, you pick it up, put it in the oven, and then it will be connected. But in the industry, big industries, electronics companies, they have got the robotic arms. It will be doing pick and place. It will do, then it will flow through the reflow oven, and then it will do everything. So there is a mass production. It's a very well advanced area. Yeah, for DSO, you will be using a hand soldering because we can't use the pick and place. We got pick and place, but because these designs are different, we cannot use pick and place. If it is only one single design, we can fabricate quickly. Second one is we should be learning hand soldering, because always we will not be having access to pick and place. So you should be having the hand soldering skills. So that is the reason we had to unfortunately cancel 2 labs. You know, if you are on Tuesdays and Thursdays. So who are on Tuesday? Tuesday lab. Thursday lab? No. So Tuesdays and Thursdays lab we cancelled because we don't have fume extractor for the soldering, because your soldering is going to start. Then instead of that, we have given you 2 options. You can join to any one of the labs in this week. And we also opened a new lab session on Fridays. I already posted on the LMS. That is from 8 a.m. to 11 a.m. So if these guys, you can join. Then after the semester break, we will be opening one more session. So whoever is on Tuesdays and Thursdays will get an email from me asking your convenient time. Like I hope I will be able to find out a good time for all of you. But remaining guys, you will not get any email. If you are not on Tuesdays and Thursdays session, you don't get an email. If you are on Tuesday and Thursday lab, you will get an email from me asking for some suitable time, because we are planning to have a new lab opening after the semester break, because that is for the soldering. Then your board, DSO board, you don't have to solder in the lab. If you got to solder, you can also solder, but make sure that your soldering iron is a good quality one. So please don't buy soldering iron a low quality one. Based on my experience, the low quality one will catch fire. So please don't buy. There are a couple of things. It is funny for you, but it happened. So number one, when you are using soldering iron, buy one with very good compliance. It passed all the tests. Don't buy the cheaper one. It can burn your house, and then if you are in a rented house, they will ask you for the compensation. Maybe in the legislation it is not covered. You should be buying some appliances that is not with compliance. So please buy soldering iron, a good quality one, if you are buying one for your use. In our labs we got the good ones. Second one is very important one. Somebody made a mistake last year in the electrical engineering department. When you are using soldering iron, please don't use mobile phone and get distracted and put mobile phone, the soldering iron down. Okay. So someone last year, I was the capstone examiner, and when I went there for the exam, the students didn't have anything to show because everything got burned. And then when I checked, it was correct. And so what happened is they worked in the electrical engineering, our electrical engineering department. They put the solder, while soldering, put it down. It caught fire. Then Metropolitan Fire Brigade came. It was a big fire. So solder, please put back on the soldering stand. Don't put it down, because it's a silly mistake people can make. Maybe you are using some phone or got a phone call, then you put it at least in the soldering station. Don't put it down, even at home. So these are some mistakes people made in the last year. So please don't repeat. Buy good soldering iron if you are buying one for the personal use. Second one is always remember to put the solder back to the place, the solder stand. Don't put it down. So it happened in the department last year and it caused a fire. Also please use the closed shoes, because some of the solder can melt and fall on your toe. So use the cover, proper covering on your toe. So pick and place machine. I already spoke about pick and place machine. So it will look something like this. See, here are the surface mount components. So pick and place machines are available for surface mount and through hole components. But in my lab we got a surface mount because we use a lot surface mount. So these are the pick and place machine. There you will be loading all the components values. Maybe 36 or 64 you will be loading here. And then here you can see the PCBs and then some seep. So this reel, it will come to this point and it will come one by one. It will dispense, and then this arm will go and pick it up. There is a camera that will go and pick it up, which component, and put it there. So why I am showing this one is pick and place is very important. You might be going for an interview to some electronics company. They might show you the pick and place. Then you should not ask, what is this one? And then the interview stopped there. They will say, thank you very much, for coming. So it will look like something like this. You will see the surface mount components. So if you want to see, you please let me know. We got one pick and place. As I said, I will be happy to show you. So it will be pick and place. You will see the roll. So you know that it's a pick and place. The surface mount. It will look like, pretty much all the equipment will look like this. Then PCB fiducials. So sometimes you see in the PCB some hole with some color change here. People put it. So this is called PCB fiducials. So PCB fiducials are used by pick and place machine vision system to accurately detect the position and rotation alignment of a PCB. So this fiducial sometimes we put when we have some kind of alignment issues, some complex components you have to align. then they will be putting some hole here. This hole is not for mounting the PCB anywhere. You will see there is a hole, and then you will see some kind of a copper track. See, this is a hole. This hole, see, you can see this is for mounting something, but then this one is not like that. It's a bit different. So when you see this type things or this type things on the PCB, then you shouldn't be thinking what is that. So that people put it, that is for pick and place machine to see and alignment, because sometimes you need a bit more alignment in the board, so that the vision system know that this is the left, this is the right, so that kind of identification. So those are the kind of markers. So fiducials are generally round pads surrounded by a cleared area without solder mask or silk screen. See, this is an example. So this is an example. So I just included so that when you see a fiducial, you should not be thinking, what is that? I never did it. So that is when you do pick and place machine, people use these fiducials when you want to do some kind of alignment. Well, without fiducials also it will work, but then people put this one when you have some components, some alignment issues, some complicated components, then we will use. Fiducials are often located at the corners of fine pitch ICs. Sometimes fiducials, they also put it near some fine pitch ICs. So one example is you may find this one, something like this or something like this near one IC. Then you might be thinking that's a mistake in a commercial board. No, that is for the vision system to identify that one is the maybe left top, and they need the proper alignment. For all the ICs, we don't have to do it, because for all the ICs, what will happen is if your pitch is your IC, the leg, IC leg is there, and then if that one is a bit broader, even if there is a little bit error, then you will mount on the pad. But if that is very thin, the pick and place machine can make a small mistake, then it will not be bonded. So then they will align it properly using these fiducials. Yeah, for you just to understand, there is something called PCB fiducials, and then that is used by pick and place machine to correct the alignment. So that will look something like this, sometimes it will look like this. Then wave solder. So solder all pins with a wave of solder. See, this is an oven, soldering oven. In that one, what you can see is the board is coming, and then they use a solder, the paste is there. So that will use just all the pins with a wave of solder, just one solder, just reflow and then solder it. So that is the industry, that's how they solder it. Then solder reflow. Solder reflow is widely used. This is what I have got, but then I don't have the automated system. Solder reflow means we already said you put the solder paste first. Solder paste, then you already mounted the components by pick and place machine. But then it's just mounted. Then you haven't connected together. Then when you put in an oven at a suitable temperature, then the solder paste will melt it and then attach to the components. And then that you can do in two ways. The less expensive way is you pick it up from the pick and place machine, open the oven, heat it to the right temperature and put it there for 10 minutes and then take it out. So that's what I do. But in big companies, they have got the thousands of boards. So then they have got a solder reflow, means it will be coming in a belt and then it is moving like the pizza, how they're making it. It's rolling, and then the temperature is there, then it is bonding, something like that. Place in an oven to melt solder with computer controlled temperature profiles with differ for solder composition and component type. See, so many PCBs are coming just passing through that high temperature, so that the solder paste will melt and attach to the components. Then manufacturer tolerances. So manufacturers define minimum clearances and track dimensions so that they can guarantee manufacture quality. So that is the reason they have got their equipment is limited. They have got some resolution issues. They have got some specifications. That is the reason when you designed your PCB, we already gave you some specifications. Track width should be like this mil, and there should be clearance of this much. So all these things we haven't made it, but we got these specifications from the manufacturer. Then usually what they do is when you submit a PCB, they will do a thorough check whether it is meeting the specifications. But then they will charge for that as well, because somebody who knows Altium should sit there and check your design, and then if there is some issues, they will come back to us. Usually less expensive manufacturers, they are not going to check it. due to two reasons. One is that is time consuming. Second one is then you have to ask for that one and pay for that one. And they will fabricate as such is. If it is not meeting the specifications, still they will fabricate. And then your track will be joined together. Then you have to cut it, or some track it will not join together. So that is the reason we already mentioned all the specifications. This should be the minimum clearance, so and so. So this will be provided by the manufacturer. So the track width, what is the minimum track width somebody can make it? Copper thickness, number of layers, track clearance. We said these two, track width and track clearance. Then via size, all these things they will say, because you can't fabricate, because their equipment got some specification. Based on that equipment only they can fabricate. Like track width, some companies they will say that we cannot fabricate less than maybe 500 micrometer track width, just an example. Then if you put it less than 500, then that will not be fabricated, because that is the minimum resolution of their equipment. Then hole sizes, they will say 1 mil, 2 mil, they will say that this is our specification. Minimum pad size, they will say minimum pad size. So what is our track clearance? Do you remember what we said? Okay. Track width. Okay. So if it is not 10, I will reduce the marks from you. No, I think it's correct. It's 10. So workflow to create a PCB. So which now you already did it. Capture schematics, run simulations, which you did front end. Select components and create a bill of materials. Create footprints and assign to the components. Place components based upon connectivity and circuits classification, function, mechanics. You already did it. Analog, digital, all the parts. Place tracks with thicknesses proportional to the current and inductance requirements. Means if you got a high current, in your DSO we don't have a high current. If you got high current, you should have thick tracks, because you need to have more current flowing. Then all these things are just silk screen, labeling, polygon pour, solid region, copper, you are pouring to the ground plane. Then run design rules test, fix PCB, and then generate manufacture ready for Gerber file. So your file, you came up to here, manufacturing. So we will manufacture and we will get in touch with you. Now prioritize PCB layout. Not all nets are equally sensitive to layout issues, and so we should prioritize based upon speed and noise. So high priority, with these things I already discussed. When you design your PCB, high speed lines should have minimum length, which I already said. In your case that is 40 megahertz, because some of you asked me a question, can I put a VIA in the 40 megahertz line? So I already emailed, please don't put a VIA, because you are putting an extra inductor. So then also the separation should be small as possible. Then so you should take into account high frequency ones. You should give the priority. Then you have to see whether you got analog ground, digital ground, all these things you have to take into account. Those are susceptible to noise. Then low priority one, some LEDs glowing, you have to turn it on, turn it off, no matter where you put it. Some push buttons, you can put it anywhere. Low speed, you can put again low speed ones, you can give less priority. You can put VIAs, it will not affect the performance. High speed multi-layer layout. When laying out a multi-layer PCB, it is important to ensure shortest possible return path for the fastest signals, which I already discussed how the return path is affecting your PCB performance or the performance of your design. Start component layout with the highest frequencies first. Make these tracks as short as possible. Ensure that there is a VIA close to return path, and make sure you have plenty of decoupling capacitors at frequencies required, low enough ESR. This also we discussed, all these things we already discussed. Then we are also thinking of changing the DSO in the coming years and make it multi-layer, so that you will be doing multi-layer board, so that the size will be again small. Because now you got to do 2 layers, but then multi-layer might be something interesting. Yeah, then another important concept is rise time or knee frequency. So how many of you studied knee frequency or rise time in your previous subject? Nobody. So if you studied electrical device modeling, you might have studied rise time knee frequency. But this is a very important concept where people can make mistake. So I am going to ask you a question. So by the way, we will be calling those coffee guys. We haven't bought you coffee. Why? Because not because we are planning to call you and show our lab. So that is the reason there is a delay. And so we will be definitely buying you a coffee. Then this is also maybe another coffee question you can think of. Then you can join those guys. When you come, I will buy coffee. Then you will be to my lab manager. He will show you all the labs. What are the stuff going on in our lab? It's not simply a coffee. So this is also a coffee question. So the question is, suppose you are working at an industry, and then your manager said the following things, manager or the group leader. So there is a requirement of designing an amplifier. So that is the question. So you can design an amplifier, but the amplifier input is, so you have to design an amplifier. So the input, you got some pulses. So the pulse is 0 to maybe I am putting some 20 millivolt, and then this width is 20 nanosecond, and then this pulse is separated by 10 kilohertz. So not 1 kilohertz. So how much is 1 kilohertz in time? 1 millisecond. Yep. So this 10 kilohertz is a pulse. This is a frequency. So from here to here it is 10 kilohertz or 1 millisecond, and then again 10 kilohertz or 1 millisecond. Then you are getting again 20 nanosecond pulse. So the amplifier needed gain maybe into 10. Then output, what you are expected is 0. Then your pulse is amplified, same frequency like this. So this is the output. So this is the input, this is the output. Yeah, so this will become 200 millivolt, 200 millivolt, 200 millivolt, and then this spacing is the repetition is 1 kilohertz, which is equal to 1 millisecond, and this pulse width is 20 nanosecond. Yeah, so this is the design. The question is, what is the bandwidth of the amplifier? Okay, you know what I'm question. So you can just find out what is the bandwidth. So how will you find out bandwidth? So you know bandwidth. So I'll give you, yeah, so you can answer this one after the break, because anyway it's going to be the 1 hour break, and after that you can think of, and maybe first 3 answers I'll buy coffee. So then I'll have 6 remaining. If you can't, then you have to buy me a coffee, or you have to give me some coffee voucher. You got my question? It's a simple question I'm asking you. I already given you all the frequencies. Then what is the bandwidth for an amplifier? See, I have given you all the specifications correctly. Usually the companies, they don't give you this much specification. They will say that we need to design an amplifier. This is the input, that's the output, that's all. Even they will not draw. You know, I think I told you the story of meeting my instrument scientist when I joined, somewhere. I think I told you the story. He called me to discuss the design. Then I went there with so many papers, thinking that he will be discussing all the designs, because that was my first job. But then he said, oh, big picture of the mission, and then he drew the block level. Then he said, this is the input, this is the output, that's all. Then the secretary came and said, after 1 hour the meeting is over. I was sitting there. Are you sure? I asked my group manager, are you sure the meeting is over? That's all. Yeah, so they don't give you that much information. They will give you only what is input, what is output, then maybe a block level diagram. So you have to find out. If you are lucky, you may get a good specification list. If you are working for a client, you may get a specification. Otherwise, you may get something like this. So this issue, how will you do it? Okay, so you can take 5 minutes break, and then we will start. by answering this question. Yeah.
Questions? I thought this Friday is a public holiday.
This Friday.
Yeah. So how about the lab session?
Melbourne Cup, isn't it? Melbourne